Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In this series, up until the last video, we spent time to set up this system, which consists of the game engine static library, which is written in C++, and the level editor, which is written in C#.NET Core framework using WPF. And because we are using two different frameworks, we needed an engine DLL that exposes functionality from the engine static library to the level editor, and that way we can load this DLL in the level editor and interact with the game engine. In the last video, we added another step, which is the Visual Studio solution that contains the game code. And we again use the game engine to link with the game code and use its functionality to create the final game. In today's video, I'd like to add another step, which is the ability to load the game code as a DLL in the level editor in order to be able to actually interactively develop the game. And that means that we need to be able to have different outputs for the game code project, depending on whether we want it to be the final executable or to be loaded in the level editor as the DLL. So today I would like to work on setting this up so that we can have different types of output, depending on whether we want to use the game code with the level editor or just have the final executable. And also to create a game code solution whenever we create a new game project using the level editor. Before we go and add new build configurations for the game code, I would like to finish a couple of things that I forgot to do in the last video. First, here in entity creation function, whenever we don't have free IDs, that means that we don't have empty slots to put our new components in. We need to create room at the end of component arrays to put the new component in. So here I did that for transform component, but I forgot to do that for the script component. So here I'll add a new element at the end of scripts array. And that way we have enough room at the end to place this new script at this position. Next, whenever we remove a game entity, we also need to check whether it has a script component, and if so, remove that script component here in the remove function. Here I call the remove function in scripts namespace to remove this script in this slot and override that slot with an empty component that has an invalid ID. One of my viewers also attended me to the fact that I made a spelling error in script registry. It should of course be script registry, not registry. And also in the creation function, when we want to remember at what index the new entity script was added, we need, of course, to take the position that's the end of the array, and that's not the size of the array, but the size of the array minus 1. What we also can do is just to move this line to the top before we add the new item at the end of the array. So if we don't subtract by 1, then it will be correct. So here we remember what the size of that array is, and then after we add a new element, then this index will point to that new location at the end of the array. Further, I made a little error in this epsilon constant that we will be using for floating point value comparison. And here, instead of doing 10 to the power of minus 5, I typed in 0, which is just 0. So I need to do this, and this equals 0.00001. And one more thing is that I want this namespace, the internal namespace in primal ID, to be detail instead of internal, because if we go back to the script namespace in game entity header, We see that we are using detail namespace here as well. And to be more consistent about what namespaces are intended to be internal, we'll be using detail instead of internal. And one last thing is that if we go back to the game project that we created, we see that we have this register script macro here in the header file. And if we look at its implementation in the engine, in game entity header, you see that we are using an anonymous namespace to make it confined to the translation unit that is using this macro. So nobody else can refer to this static variable basically here in this anonymous namespace. But since we are using it here in a header, it doesn't really make sense because an anonymous namespace in a header is accessible from anything that would include this header. And in order to prevent that from happening, we can just move this line from the header file to the translation unit, which is the CPP file. And now this rec character script variable that we are creating here can't be accessed by anything outside this translation unit. So this was all it was left to do from the last video, and now we can start adding new configurations for the game code project that we have here. Going back to the drawing, we can see that we need 2 additional configurations for the DLL, one with debug and one for release. Here I can add 2 new configurations. Go to Configuration Manager just by clicking this button, or we can also access that from here, Configuration Manager. And here at the top, I can just add new configurations that would generate DLLs instead of executables. And since we are using those with the editor, I just call them debug editor and release editor. And luckily, we can just copy settings from the existing configurations that we have, so we don't have to set it up again. So this one was for release editor and one more for debug editor. Now, if we look at the properties for this project and select one of those configurations, we can see that everything that we set for the debug and release is also here in these new configurations that we just made. So this force include file, for example, is here. And because this debug editor is, well, obviously a debug build, then there should also be no optimization enabled, which is true. And if I would select release editor, then the optimizations would be enabled. And that's right. And the only thing we now have to do is to change the output type to a DLL instead of an application. So here we see that the configuration type is an application, which outputs an exe.exe file. And then I can change it to a DLL. Apply. And the same for debug. One more thing that was pointed out by one of my viewers was that this fast call calling convention only applies to x86 architecture, which is 32-bit. But since we are using an x64 architecture, which is 64-bit, according to Microsoft's documentations and this article on Wikipedia, all conventions that we set here, whether it's fast call or cdecl or dyscall or standard call, will resolve to this Microsoft x64 calling convention, which puts the first 4 arguments of the function on these registers, RCX, RDX, R8, and R9. And if they are of type floating point, then these floating point registers will be used. So it doesn't really matter if we set this to fast call or anything else, except vector call, obviously. So this doesn't have any consequences, and we could basically ignore this. So thanks again for pointing that out. Next, in the new configurations, I would like to set a couple of preprocessor definitions as well. One is just to indicate that we are using this with the editor. And the other one is that we are on a Windows platform because the editor is obviously Windows only. We are using WPF. And do the same for release editor. I need to remove this console, by the way. We are not creating a console application. So going back to debug editor. So this is all we have to do to have 2 more configurations. The next thing we need to do is to automate the process of generating this Visual Studio solution for the game code using the level editor. And to do that, I'm going to look at the solution and project files as they were made by Visual Studio itself. So I'm going to open this solution, the content of it, and also the project file. So here we can check what we need actually to generate this file using the level editor. Here we can see our build configurations. It's for debug, debug editor, the release and release editor. Because I'm not able to generate this whole solution file and the project file, I'm just going to use this as a template for the new projects that we are going to create using the level editor. That means that when we use this file as a template, we need to fill in some parts that are unique for each game project. For example, the name of the game project will be different, obviously, and therefore also the name of the Visual Studio C project file. We need also a new globally unique identifier for this project, and a globally unique identifier or a GUID for the solution. And you can also see that this ID is the same as here. So we need to fill this in, which is the same number. And the way I can do that is just by reading this file in as a string and then string format it with whatever I want to put in here. So for example, I need the name of the game to be the first parameter that I will be filling in here. We are going to put the game code in a game code folder in our game project. And this part again needs to be the same as this parameter that we are filling in. And we'll be generating this GUID here. So that's the second formatting parameter that we fill in, as well as all of this. And the last parameter that we need to fill in is this solution GUID. So that's number 2. And because we are using string formatting, that means that whenever we have curly brackets, we need to make those double, because otherwise the formatting function will think that we need to format this as well, which is not the case. This GUID is just an ID for the project type that we are making, which is the Visual Studio C project. They all have this GUID. And I think that's all we have to do. So I can save this as one of those template files in our game project templates. So this will be save as, going to Primal, Editor, Project Templates, and I'll put this here as MSVC solution. And I won't be using an extension for this, it's just a template file. Okay, next we are going to look at the project file itself. Here are more settings that we need to fill in after we turn this file into a template. So here we have project configurations. And here there are compilation settings and linker settings that we set in the properties, in the solution properties. And there are parts here that we need to fill in after we create a new game project. As I mentioned before, this calling convention setting doesn't apply to the platform that we are using, so we can remove it. Now, if I save this and I reload this project, then we should be back to cdecal, which is the default. And it's the same as fast call and standard call in the platform that we are using. So let's start from the beginning and see what is different for each project that we are going to create. So obviously this will be the same for all projects. This is the name of our project, so we need to fill this in. And we have a project GUID. We need to fill that one in. I'm just going to move this down a bit. So we have 0 and 1. The order doesn't matter, but it's just to be easier for us to read if they're not in a random order. Windows target platform version is 10, and Visual Studio will automatically pick the latest SDK that you have installed. So we will leave this as is. And then we don't have to change anything here. Here is the application output and dynamic link library output. So that's okay. And these are the same for all projects. And these are the same for all projects as well, so we don't need to do anything. I would like to change the warning level to 4 here. So actually for all build configurations, I'll change the warning to level 4. So we arrived here, and these are the compilation options and linker options. First of all, we are not creating console applications, so this console definition can go away here as well. Actually, this part is the area that we should concentrate on changing or templatizing, so we can reuse that for different game projects. So until here. After that, we have the files that we included. Well, these we don't need because we'll be adding the script component files after we create a new project, so I can remove these. And now we are just left with 4 scopes for item definition groups for each build configuration that we have. So starting with the first one, which is the debug. We don't need SDL checks, because everybody could be using a different path, of course, for the primal engine. I want to create a macro that we can reuse. So a macro is something like this $sign and then user root directory. And Visual Studio has a bunch of these predefined, and we can define user macros like this as well. But I can't really find where in this Visual Studio interface should I look to make those kind of user macros. I searched the interwebs as well, but it didn't give me an answer for this version of Visual Studio. And frankly, I don't really care because I can just edit this file and add our own user-defined macros. And the way that we can do that is by putting those here, user macros. So I'm going to add 2 new user macros. I'm going to call those primal include path, which I'll be filling with a 3rd parameter. So remember, we have 1, 2, and the 3rd parameter that we need to fill in this template is the path to primal engine where it is installed. And then I'm going to define 1 more for the library path. And here I'll fill in the 4th parameter, which is a root folder for primal engine. So in our case, it is the primal, followed by the platform name and the build configuration name. And now we can build our user macros in a new item group. Okay, now whenever we need to use this, we can just use these macros. So for example, the additional include directories will be just this include path, which is easy. And the subsystem will be the Windows for now, because the only platform we are supporting right now is Windows. And here in additional library directories, we can use this macro. So remember now that we have 4 configurations, And if we are using debug editor, then this primal library path will go to the wrong path because it doesn't exist in our game engine project. In our game engine project, we only have debug and release right now. So we also need to add a debug editor and debug release build configurations to our game engine project and solution as well. But I'll do that later. For now, I just want to finish this first. So we set everything that we need here for debug configuration, and we can just repeat that for the other configurations. Okay, I think we set everything that we need to set here. I think I'm going to also remove this window definition that we added, because if we set windows for subsystem, then it will automatically define some preprocessor definitions that we can use to determine if we are developing for Windows or not. Okay, let's do a last check to see if we set everything that we need to set. I would also like to have no runtime type information. Actually, that's a compiler setting, so I need to put that one here. Okay, I think this is all we have to do. So I'm going to save this as one of the template files again. This time it will be an MSVC project. So now in our game engine project, we can go back to the level editor, and whenever we create a new game project, we also create a new Visual Studio solution. Here in create project, I'll add a new method, create MSVC solution. And we give it the templates that we are using, the project template, and the path. So let's generate it and fill it in. So first I'll assert that those solution and project file templates that I just copied to our project templates exist. Because right now we don't have the root folder for our project templates, I don't know where to look for these files. So I need a new property in the project templates class that will remember the root location for the template. So here I just added a new string property. And where we look for our project templates, I can fill that in. Remember that we look for template XML files in this template path location. And this is the base directory where all templates are located. And for each file that we find, we have, of course, a new template directory or template path for that particular project template. And this is here how we get that path from the file name, which contains the full path, of course. Next, we need the path where the game engine itself is located. So here we need the root folder for Primal Engine. And because we are looking for engine API path, we append engine/engine API directory at the end of the root for Primal Engine. And because we don't know yet where Primal Engine will be installed, I'll just create a new static property. And normally when this engine is done, or at least version 1 is released, we will have a nice installer that will install the binaries of the engine to some location that user specifies. But right now we don't have that, of course, because engine is in development. And well, in my case, I have it here in Z Primal. But of course, everybody could have it in another location. So going back here, this way we now have a location for where these include files are located that we can use. And also I need to assert that this directory exists. Okay, next I'm going to read these files and fill them in with the parameters that we need to fill in to make them a proper solution and project file for Visual Studio to open. So remember that we need to fill in these parameters in solution file. So the first one that we need to fill in is the name of the game project. So here I'll define the first parameter, which is the project name. And the second one is a GUID for the project. So I'll generate that here. Now I can fill this in here. So _0 goes to the first parameter, _1 goes to the second parameter. And we also need a GUID for the solution. And that one I'm just going to create here in line. So now we have the text for the solution, and we need to write it back to the location where we are creating our game project. So we construct a full path for the solution file that we need to create, which has the name of our game project, and then write this text that we just filled in to that newly created file. And then we can do the same for Visual Studio project file. Let me actually just copy paste this block. Okay, let's see what parameters we need to fill in for a project file. Again, going back to this template that we made, we have the root namespace, which is the project's name, basically. So for example, in this case of our own game project, here the namespace would be first game project. And the project GUID, again, Those we have here already. So this one is the project name and the project GUID. The third parameter is the location of the include files from Primal Engine. So here we have the engine path, and then I can just do this. And the last one is the location of Primal root directory, which will be appended by platform name and configuration name. Okay, and then again, we write this to the MSVC project. And we should use this project string that we just read and modified. And if we did everything okay, this will create a Visual Studio solution for us that we can use to add our game code scripts to. Let's see if that works. So let's create a new project. And now if we go to the location where this game project is created, hopefully we'll see a solution and a Visual Studio project. So remember that we create the game projects in the documents, Primal projects, and we have here our awesome game. And now we have the solution file and a project file, but I would like this project file actually to be in the game code folder. So I need to fix that. Let's close this. Of course, I need to type in game code here. Otherwise, it will go to the root folder for our game project, which is not what we want. So now let's remove the game that we just made and create a new one. And here we have our awesome game 2. And this time the Visual Studio project is created here. If we open and have a look at it, we see that the namespace is awesome game 2. Our GUID is created here. And we have the location of the include files. And we have the location of the engine library here. And all the rest is the same. And in theory, if I would now double click this solution, Visual Studio would open it. So here it is. We successfully created a Visual Studio solution and a project that would contain the game code. Okay, good stuff, fantastic. Next, I'm going to make something that will ask the user where Primal Engine is located on their system the first time they fire up this application. Going back to main window, when we start a window, I'm going to ask the user where Primal Engine is. So in order to remember where the engine is, we just set an environment variable. Here we check if this environment variable is set, and we can get its value if it is set. And if not, we can ask the user where the engine is located and then set this environment variable. So first check if this is set. Okay, here I check if we can get the value of this environment variable. which is primal path. So to ask the user where the primal engine is located, I need to open a dialog with a text box in it where the user can fill in the location of the engine. Okay, so now I need to implement this engine path dialog. Therefore, I'm going to add here next to main window, I'm going to add another dialog window that I can use for this. Okay, here I'm going to use the primal dialog style for this window. And it's basically a border with a text box in it. Okay, within this border, I have a text block for error messages. So if the user types in an invalid path, then this text block will contain the message that will say what is wrong with it. Next, I put the text box where we can fill in the location of the engine. This light text block style makes sure that the color of the text is right and it's centered vertically. So now we end up with something like this. And of course, I need two buttons to set or cancel this operation. So we need an OK button and a cancel button. Now we have two buttons, one for OK and one for cancel. And since cancel just closes this window, we don't have to have any click event handler. And for the OK button, we need to implement this on OK button click event handler. So I'll press F12 and it will create this function for us, which we can then fill in. Here, I'll just get the text from the text box. Here I'll examine what the user typed in, and if it resulted in a valid path, I'll put it in a public property that the calling window can use to retrieve the path that the user typed in. Okay, the next thing I'll do is to examine this path to see if it is valid. Okay, here we examine the validity of this path. So if it's empty or it's null, then obviously it's an invalid path. If it contains any invalid characters, it's also invalid. So we set the message text box to tell the user that it has invalid characters. And finally, we check if this directory exists. If we append engine API to the path, it should yield the location of the include directory. And if not, then we should tell the user that we weren't able to find that particular directory. And if these are all not the case, that means that this path is valid. And then we can set this primal path to the path that the user typed in. So if message text block text is null, that means that we don't have any error message, therefore this path must be valid. And we check if it ends with a backslash or a directory separator. And if that's not the case, we just append a backslash to the end of it. So it's a valid path format. And then we set the primal path property here to this path value and return true and close the dialog window. And now in the main window, we can create an instance of this dialog window and check if its result was true. If not, we close the application because we can't go further without knowing where the engine is. And if we know where the engine is, then we can use the string that is in this dialog window to set the environment variable for primal engine. Here we set a new environment variable for primal engine using the primal path that we got from the dialog box for the current user. I also need to make this window not resizable and also set its initial position when it opens. And I need to also set the owner of this window in the code behind. And now we can see that because this environment variable is not known right now, the editor will ask us for a location. So for example, I can type in some nonsensical value, and then if I say OK, then it will tell us that that location doesn't exist. And I can type in invalid characters. OK, that's right. Now, if we would open the command console window and type in set, it will show us all environment variables that are set on this machine for this user. So right now there is no variable set for primal engine, as we can see here. But now if I would type in the primal, yeah, I needed to restart command prompt, so it would refresh the contents of the environment variables that were set. And now you can see that there is this primal engine environment variable that contains the primal. And from now on, whenever we start the engine, it won't ask us again because that variable is persistent and it will just start the engine. Good, that's all I wanted to do for today. And next time we will look at how we can add files to this new solution that contain the game entity scripts and how we could build the solution and load the DLL in the level editor. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!